Yo, what up, dog? This goes out to my homies in first hour. What up, yo? Alright, this is your one and only Educanon video for this unit. It's a short unit, it's a quick unit, it's mostly review from what you have learned about last year, but we're going to kind of review and go a little bit further than where you went last year. So first we're going to talk about the categorization of the different layers of Earth, right? Two categories. We've got the structural and then we've got the compositional. Right? So structurally is made up of 5 layers. Compositional layers are made up of 3. All right. So if we look at your circle is not going to be filled in like mine is, but I expect you to have something similar to this, right? So we start on this outer blue edge, and that is called my lithosphere. It's a very thin layer. It's the crust and the upper portion of the mantle kind of includes that lithosphere. And then we move from the lithosphere to the asthenosphere. And the asthenosphere is this plastic type part of the mantle that sits below the lithosphere and above the mesosphere. Okay? So the green is my asthenosphere. And then we get into the big chunk of Earth, which is the mesosphere. In Latin, meso means middle, okay? So the yellow is my mesosphere, okay? And then once we get from past the mesosphere, we get into the outer core, right? I'm just going to put OC, and then we get into the inner core, okay? IC, right? So here's the outer core. The outer core, again, is the liquid portion of the core, and then the inner core is the solid portion of the core. Both the inner and the outer are both made of nickel and iron, but the inner core is a solid, immensely, unfathomably dense core, and then the outer core is a liquid core, and that outer core is where our magnetic field is generated from. Okay, so that's the structural setup, right? That's the structural setup. And then over here, we've got a much simpler compositional setup, right? We've got this red line that goes around, right? That red line is like the skin of the apple. It's called that's right. It's called the crust. And then we get into the gray area. The gray area makes over 2/3 of our Earth mass up. That's the mantle, right? And then we get into the puke yellow color, which is the core. Compositionally, we've got 3 layers. Structurally, we've got 5. Okay? Now, moving down, answering these questions, right? What determines whether the interior layers of Earth are solid or liquid? Like I told you, some of the mantle areas, right? The asthenosphere, the mesosphere, the lithosphere, some of that's solid, some of that is liquid. Inside the core, some of it's solid, some of it's liquid. What truly gives us that? Well, 2 different things. It's temperature and it's pressure. Right? If it's hot enough, right? If it's hot enough, it's going to melt. But if it has so intense pressure, it may turn it back into a solid. That's why the core, the inner core, is a solid, because there is so much pressure pushing down on that material that it condenses it back into a solid, okay? But then when we get to the outer core, there's still a massive amount of heat, but the pressure is less than the inner core, and therefore it's a liquid, right? So it's the heat and pressure of the layers that the layers are under. That's what causes what's to be a solid, what's to be a liquid, okay? The greatest part of the volume of the interior of the Earth, we've talked about it, 2/3 of the Earth is made up of the mantle. What about the smallest part? The skin of the apple, right? The crust, all right? Now, if we talk about that crust, the skin of the apple, where is it thickest? Is it going to be thickest on the continents, or is it going to be thickest in the ocean? It's going to be thickest on the continents. Where specifically on the continents? By the beach, hanging out, getting the suntan? Or is it going to be on top of Mount Everest? Okay? We see mountain ranges. That's where the thickest portion of our crust is. On top of mountain ranges is the thickest portion of the crust. Okay? Now, this table, you need to start filling out this table. Let's first talk about oceanic crust, right? Two different types of crust. You learned over there, you learned last year. Two different types of crust, oceanic and continental. Oceanic, we vary from 5 to 10 kilometers thick. The density is 3.0 grams per centimeter cubed. You don't need to know that the actual density, but you do need to know that it is denser than continental crust. And it's made mainly from basalt. And what kind of rock is basalt? Think of how ocean crust is made and tell me, what kind of rock is basalt? Is it igneous? Is it metamorphic? Is it sedimentary? Answer that now. All right? And then we only see what we've found out now, currently, we only see that rocks that are about 180 million years old. Okay? Pretty young rock in comparison to the age of Earth. 4.6 billion years. We only see rocks that are 180 million years old. Okay? So there's the oceanic crust. And then we see continental crust, and we can compare the two. Continental crust, much thicker, like we said in our last slide. Much thicker, 15 to 80 kilometers thick. And the density, which one's more dense? Oceanic crust is more dense, and therefore, if oceanic crust meets continental crust, where's the oceanic crust going to go? It's going to go down underneath the continental crust, pushing the continental crust up, right? So that's where the density comes into factor. Where the oceanic crust meets continental crust, the oceanic is more dense, so it's pushed down into the mantle. Continental crust is pushed up, right? And so we've got a difference in density, and then we see continental crust is made of all types of rock. Okay? Oh, I didn't answer this. Right? Basalt is an igneous rock, if you didn't get that right. And then here we see all sorts of types. Igneous, metamorphic, and sedimentary. We see all those types in continental crust. And we also see 4 billion year old rocks. 180 million, 4 billion year old. So we see rocks that are almost as old as Earth here on the continents. Now, what about both? What do both have in common? Both oceanic and continental crusts are cooler than the core. Hence, that's why they're on top, because they're cooler, and they're less dense. They're lighter than the mantle, right? So they sit on top of the mantle like ice cubes float in water. The crust is less dense than the mantle, so it sits on top of the mantle. And they are both made of solid rock, all right? If we look down here, we look at this picture. This shows you, here's my oceanic crust, right? There's my oceanic crust. Neither one of those show up very well, but there's my oceanic crust where it meets a continental crust. And what's happening to it is it's being pushed down underneath. What's happening to the continental crust? It's being compressed and pushed up, right? It's being pushed up. Okay, so we'll talk more about that in our later units, but that's just kind of an overview of oceanic crust versus continental crust. Now, what I want to do is I want to move to talking about a couple of the different layers with regards to the compositional layers. Is that the compositional? Yeah. So the compositional layers, remember composition has 3 layers, right? The crust, the mantle, and the core. If we talk about the crust is the outermost layer. It's the least dense, and it takes up less than 1% of the total of Earth's mass. It's the skin of the Earth, right? It's the skin of the apple, okay? And then we move to the mantle. The mantle is denser than the crust and is nearly 2,900 kilometers thick, over 2/3, right? Oops. 2/3 of Earth's mass is in the mantle, right? 2,900 kilometers thick. And it makes up, here's our next one, makes up 2/3 of the Earth's mass, okay? And then we go to the core. The core is denser than the mantle and the crust, and it is extremely hot. Why is it hot? 2 reasons: gravitational contraction and radioactive decay. Okay, it's extremely hot, made of mostly nickel and iron, and made of roughly 1/3 of Earth's mass. So we've got 1/3 here, we've got 2/3 here, and then we've got a fraction for the crust. Right? It's the skin of the apple. The meat of the apple is what we eat, right? That's the mantle, and then we've got the core where the seeds are. That's kind of the general makeup of Earth. Now let's take a look at the structural layers, right? Structural layers. The lithosphere is the upper rigid portion of the mantle, right? It's 15 to 300 kilometers thick, anywhere from 15 to 300. Where is it going to be 300? By the beach or in the ocean or in the mountains? In the mountains, right? And then we move down into the asthenosphere. The asthenosphere is about 200 kilometers thick. Because of the tremendous heat and pressure here, solid rock begins to flow. This is called plasticity. So solid rock starts to melt and begins to flow, and therefore starts to have this oozing effect where we see magma and lava. Then we move to the mesosphere. Meso meaning middle. Middle is a solid rock layer, okay? And then we've got the outer core, which is believed to be a dense liquid and where Earth's magnetic field is generated from. And then the last one, very dense, rigid core. Solid core surrounded by liquid outer core, right? Nickel and iron. And then that's surrounded by a solid middle layer, the mesosphere, with a liquid asthenosphere layer on the outside of that, where we see majority of our magma and lava. And then we've got the rigid upper portion of the mantle top crust, which is the lithosphere. Right? So these pictures, I didn't go into them, but it gives you the compositional layers, mechanical layers, same thing. Mechanical means structural, right? So the structural layers, compositional layers. That is it. It's a quick video. You're probably going to have to pause it a couple times. I'm talking really fast, but this is the information, and this is really not an all-inclusive list. I've just kind of popped in highlights of the different layers and how they separate them as scientists, all right? So we're going to talk more about this in class, but this was your only educational or educanon video for this unit. Peace out, people!